Today in this video, let us discuss simple slop detector. A simple slop detector is a very basic circuit used for the demodulation of frequency modulated signal. And before going to the details of a simple slop detector, let us discuss about the FM detectors. An FM detection or demodulation is a key process in the reception of frequency modulated signal. That is, once the signal has been received, filtered and amplified, it is necessary to recover the original modulating signal from the carrier. So this is performed by a circuit called a demodulator or detector, or even we can call it by name discriminator. Now we will go for the requirements of FM receiver. First is, it must convert the frequency variation into amplitude variation. Now, in order to be able to demodulate a frequency modulated signal, it is necessary to convert the frequency variation into voltage variations. It is done by using a frequency to voltage converter, and this conversion must be linear and efficient. That is, it should be able to have a response as linear as possible over the required bandwidth. That is, a shift in the input frequency must produce a proportional or a corresponding change in the output amplitude or the output curve. If the response is not linear, then distortions will be introduced in the output. It should respond only to the frequency changes. That is, a circuit should not be sensitive to the amplitude variations, as because the modulation is carried only for frequency deviation, and any change in the amplitude or the amplitude variation signal is likely to be a noise. Thus, by making the receiver insensitive to amplitude variation, the signal to noise ratio in the receiver circuitry can be improved. And next requirement is, it should not be critical in its adjustment and operation. That means that the circuit should be flexible and user friendly. Now we will go to the type of F1 demodulator. There are several types of F1 demodulator circuit, and this can be categorized under two main sections. One is a direct type and second is the indirect type. In direct type, we have slop detectors and the phase detectors. The slop detectors works with the frequency discrimination method, and there are two types of slop detectors: simple slop detector and a balanced slop detectors. And the phase detector types are Foster-Seeley discriminator and ratio detectors. The indirect type detectors are PLL detectors and quadrature detectors. Now this figure shows the block diagram of a simple slop detector. It consists of a frequency selective network. It is also called as a frequency discriminator, and it is followed by an envelope detector. The input to this circuit is a frequency modulated signal with a frequency of Fc, carrier frequency or the center frequency. This signal is applied to the frequency selective network or a frequency discriminator. The output of the frequency selective network is an amplitude modulated FM signal, which is then given to an envelope detector, and we get a final modulating signal or the original message signal from this envelope detector circuit. Now let us go to the circuit of a simple slop detector. So this figure shows the circuit of a simple slop detector. As I told you earlier, in the block diagram, it has got mainly two blocks. One is a frequency selective network or a frequency discriminator, and second is an envelope detector. The input to this circuit is a frequency modulated signal with a frequency of Fc as a carrier frequency or the sender frequency, and a frequency deviation of delta f. This signal is applied to the discriminator circuit, which is mainly a tank circuit made by using the secondary of a transformer and a capacitor C. This tank circuit is so tuned for a resonant frequency F0, and the resonance frequency F0 is made to be greater than the input frequency Fc, or the resonant frequency is adjusted to F0 is adjusted to Fc plus delta f. I repeat, the tank circuit is made to be, the resonant frequency of the tank circuit is made to be greater than the input carrier frequency Fc, and by doing so we will be able to receive the signal on the slope of the response curve of the tank circuit, and this is the reason why we call this circuit as a slope detector. And this figure shows the response curve of a tank circuit or a tuned circuit. Now, the amplitude of the output voltage of the tank circuit depends on the frequency deviation of the FM signal. This change in amplitude results because of the change in the magnitude of the impedance in the tuned circuit as a function of frequency. Thus, change in amplitude results because of the change in the magnitude of the impedance of the tuned circuit, impedance in tuned circuit as a function of frequency, and this results in effective conversion of the frequency modulated signal to an amplitude modulated signal. The output of this discriminator is applied to a simple diode detector with an RC load with a proper time constant, and this detector is identical to an AM diode detector. The output of the envelope detector is the original message signal or the baseband signal. Now let us go back to the response curve of the tuned circuit. So here we have a message signal with a maximum amplitude, I am going to assume it as 7 volt, and a minimum amplitude of 1 volt, and a carrier with a maximum amplitude of plus 10 volt and minimum of minus 10 volt. Now what happens in FM? As the amplitude of the message signal increases, the frequency of the output signal increases. So this high frequency is 1500 kilohertz. Now as the amplitude of message signal decreases, here the message signal amplitude decreases to 1 volt. Now the frequency of the output signal decreases. So let this frequency is equal to 150 kilohertz. Now this signal, we are going to give this signal, this FM signal to a slope detector circuit to recover the message signal, So this frequency modulated signal is now going to, in the slope detector, this FM signal is now going to a frequency selective circuit and an envelope detector where we get the original message signal. Here now we will go to the response curve of the tank circuit or a frequency selective network. This is a graph showing gain versus frequency, and here at one particular frequency the amplitude of the output signal becomes maximum, and this frequency is said to be the resonant frequency. Now the maximum value of input signal we have seen here is, we have taken it as 1500 kilohertz, and the resonant frequency of the tuned amplifier should be greater than that of the input frequency. So let us take this frequency as 1700 kilohertz. Let us apply this frequency to the input of a slope detector. So this signal will get coupled to the tuned circuit at 1500 kilohertz. Now the response curve is showing 0.7. That means that at a frequency of 1500 kilohertz in FM signal, the output of the tuned circuit will be 0.7 into 10. 10 is the amplitude of the carrier into 10, which is equal to 7 volt. Now at a frequency of 150 kilohertz, here the response curve is showing 0.2. That means that at 150 kilohertz, the output of the tuned circuit is 0.2 into 10, which is equal to 2 volt. Now at the output, we get a amplitude modulated signal that varies from 7 to 2 volt. So this signal is given to an envelope detector where we get the envelope of this AM signal as the message signal. Now this tuned circuit has got a disadvantage, a problem. That is, this circuit is a non-linear circuit. Due to this non-linearity, we get some or other form of error in the output signal. Now look at the input signal. Here the signal varies from 7 volt to 1 volt. And due to the effect of non-linearity, here the output signal varies from 7 to 2 volt. And this error, that is the error that occurring due to the non-linearity, is called as a slope error. As because this error occurred due to the slope in the response curve of the tuned amplifier. To minimize this slope error, we go for a balanced slope detector. Now let us see the advantages and disadvantages. A simple slope detector circuit is simple and inexpensive, and the main disadvantage is that it shows a non-linear characteristic. That is, the circuit shows linearity only over a limited range of input frequency. See, here only in the response only this portion we have a linear portion, and here the circuit output will be non-linear. So the circuit shows a linearity only over a limited range of the input frequency. Second is the output is sensitive to the amplitude variation in the input. That is, it transfers even the slightest amplitude variation to the incoming FM signal. Variations of the incoming FM signal to the output. So which results in the distortion, or the true modulating signal cannot be will not be recovered in such sensitive conversion. That is all about the simple slope detector. Thank you for watching this video. Thank you.